Hello guys, welcome to Brainwave Academy. Today we are going to look at how to solve this question. We don't know which formula we're going to use. In this video I'm going to show you how to get your own formula. As far as you know the general formula, you can get the formula to solve this question. The question goes this: a fixed mass of air at STP means standard temperature and pressure, is heated such that its volume remains unchanged. What is constant here is volume. Volume is what? Constant. For me to hear this statement, I can get my what? Formula. So we now say solution. As far as I know the formula, I can get what? Formula for Charles law, formula for pressure law, formula for what? Boyle's law. From what? General gas law. So what I will just write my general gas law. P1, V1, all over what? T1 is equals to P2, V2, all over T2. Now, what is unchanged here is volume. Volume is unchanged, which means volume is kept constant. I'll clean my volume. If I clean my volume, I'm going to have P1 all over T1 is equal to P2 all over T2. This is the formula to solve this question. Now, that is the first thing. Now, I can also use this formula to state this law, which is pressure law. The pressure law states that the pressure of a given mass of a gas is directly proportional to what? Temperature, provided that the volume is what? Kept constant. You see from the formula I can state the law. Now let's move forward. For this one, at standard temperature and pressures, STP, I have two temperature, which is what? We have temperature in degree Kelvin and temperature in degree Celsius. If I say standard temperature and Kelvin, we have to come and check which value they give me. They give the what? The next pressure in what? Centimeter. And standard pressure in centimeter is 76. While standard pressure in millimeter is 760. So now that they measure centimeter, which means my P1, because only this statement can make you to get P1 and T1. P1 is equal to 76 centimeter hydrocanadian. While T1 is equal to 0 degree centigrade. 0 degree centigrade. And how can you convert this? How to convert this temperature to what? Kelvin. We have T1 is equal to 0 plus 273. It is what? 273 Kelvin. I'll get from this standard temperature and pressure, I get this value. P1 and T1. Then I'll move forward. As STP is heated such that its volume remains unchanged, calculate the temperature, which means you are looking for T2. T2 is unknown. When the pressure increased to what? 114, which means P2 is equal to 114 centimeter of mercury. That's hydrocanadian. Assuming they bring this one in millimeter, the pressure P1 is supposed to use 760. But now they bring in centimeter, I'm going to use 76. So now we are going to input all the data collected into this formula, which is what? P1 all over what? T1 is equal to what? P2 all over T2. What is our P1? P1 is 76 all over T1. T1 is 273 is equal to P2, which is 114 all over T2. Very easy, right? So you cross multiply 76 times T2, we have 76 T2 is equals to 114 times 273. We now have 76 C2 is equals to 114 times 273. We have TV1, 31,122. So now that we are looking for T2 and the unit of T2 is 76, we have to divide both sides by 76 and 76. This cancels this. We have T2 is equal to 31,122 divided by 76, which means we have 409.5. The first temperature we convert it to what? Kelvin, which means this one is also in what? In Kelvin, which is Kelvin. So T2 is in Kelvin. We can decide to change it to a degree Celsius by subtracting 273 degrees, which is T2 is equal to 409.5 minus 273, which means T2 is equal to minus 273. There is 136.5 degrees Celsius. Because they may see some question, they will say you should what? Put it in degrees Celsius. You have to convert it by subtracting we're subtracting 273. Please do well to subscribe to this channel. Thank you and peace out.